In this video, we'll introduce to you the fundamentals of function generators, which create a basic waveform, and oscilloscopes, which display or measure a waveform.
First, we'll show you the function generator. The main purpose of this device is to produce waveforms which can be used to modulate circuits or other devices. Here are some basics of its theory and operation. Note that the cable is connected to the single output channel of the generator. There are also a trigger output and a trigger input that can be used for timing purposes. You will need to press the channel on button to enable the output. The generator can produce sine waves, the most commonly used waveform, square waves, essentially switching between two voltages, and triangle waves. Note that when switching to a triangle wave, there is a lower maximum frequency, and the generator will adjust its frequency accordingly. It's also capable of producing pulses and arbitrary waveforms, but we won't cover those here. There are many properties of a waveform that can be adjusted. To change the frequency, you can press the frequency period button, or you can press the frequency period phase menu. The large knob can be used to change the values relatively smoothly, or you can type a number and press enter. To change the amplitude, you can press the amplitude high button or go into the amplitude level menu. Similarly, you can adjust the period, phase, and voltage offset. Lastly, note that there is a trigger output to provide flexibility and synchronization.
Next, we'll show you the oscilloscope, which is useful for measuring waveforms and seeing the effects that a function generator has on a circuit or device.
Once the scope is on, ensure that the appropriate channel is displayed. Here we have a signal in channel 1, which is yellow. You can press the yellow 1 button to enable or disable its display. If there was a signal attached to channel 2, you could press the blue 2 button to display it. Note that the displays are color-coded for convenience. You can also use the red Math button to display mathematical operations on the channels in real time, for example, adding, subtracting, or multiplying the two channels, or performing a fast Fourier transform on one of the channels. Now let's focus on displaying the attached signal. Since the amplitude is too large to fit on the screen, we will adjust the vertical scale using the dedicated knob under the yellow 1 button. We will also adjust the horizontal scale with the appropriate knob to display a suitable number of waveforms. You can also adjust the vertical or horizontal position using the smaller knobs above the channel buttons. Note that each channel has its own dedicated vertical controls, and there are shared horizontal controls to ensure that the timing remains consistent between the two channels. Now, we will look at the trigger function, which ensures consistent timing on the display. As we turn the trigger level knob, we change the value at which the scope starts acquiring a run. As such, the display will appear to shift horizontally until the trigger level is larger than the signal amplitude, at which point the oscilloscope will not have any timing information and the wave will not appear stationary. The Set to 50% button is often useful as it places the trigger level at the midpoint between the signal's highest and lowest points. It is also possible to use an external timing source, for example, the trigger output of a function generator, by attaching it to the trigger input on the oscilloscope, pressing the trigger menu, and setting the source to external. The scope can also measure useful quantities for you. One way to do this is to press the cursor button, enable a cursor, in this case we'll choose amplitude, and adjust its level to the maximum vertical height of the signal using the knob. Next, select cursor 2 and adjust its level to the minimum signal height. Now, you can read the amplitude of your signal by checking the delta value on the display. Similarly, you can change from amplitude to time and use vertical cursors to measure horizontal distances, which are times, for example, the period of a wave. Perhaps an even easier way of using the scope to measure waveform parameters is by pressing the Measure button. This allows you to automatically measure frequency, peak-to-peak amplitude, period, mean, phase, and a few other potentially useful parameters. Up to 5 of these can be displayed simultaneously. Next, let's assume we have a noisy signal that we want to clean up. The scope can help us with this. Press the Acquire button. You can now change from sample to average and select a number of sweeps to average, up to 128. Note that this is a running average, and as such, the more sweeps you average, the longer the scope will take to adjust to any changes in the signal. Another handy tool is the so-called magic button, officially the AutoSet button. Pressing this will cause the scope to attempt to choose vertical and horizontal scales, positions, trigger levels, etc. that are appropriate for the attached signal input. Note that this will essentially reset all scope settings, including unsetting any averaging. There's also an auto range button, which I include here not so much because it's useful as because it's good to know about in case you notice this behavior accidentally. What it does is automatically adjust the vertical scale whenever the displayed height gets too large or too small. Here I've only increased the signal, but you can see the display automatically shrink the displayed wave by changing the scale. In some cases, you may wish to display Lissajous figures. You can press Display and change format from YT to XY. The scope will then display channel 1 on the X-axis and channel 2 on the Y-axis. The scope also supports USB connectivity. You can plug in a USB drive and save a waveform to a CSV file, which can be opened in Excel. To do this, press Save Recall, select Save Waveform, select Save to File, and press Save. The scope can also be attached to a computer via USB and the data transferred directly via the appropriate software.